Expected value or expectation. This is often used to determine the expected results of an experiment over the long term. People use expectation to make important decisions in many different areas, like in business to predict future profits of a new product, or insurance industries use expectation to determine premiums. So insurance companies, can make a profit. Expectation is also used to predict the expected gain or loss in the games of chance. Like, for example, consider the following scenario. Tim tells Barbara that he will give her $1 if she can roll an even number on a single die. If she fails to roll an even number, she must give Tim $1. So here comes the question. Who would win money in the long run if this game were played many times? Well, in this situation, we would expect in the long run that half the time Tim would win and half the time he would lose, right? Because there's three even numbers and there's three odd numbers on a single die. Therefore, we would expect Tim to break even. Now, mathematically, we would write it like this. Tim's expected gain or loss would be, we would have the probability that Tim wins times the amount of money that he wins, right? Plus the probability that Tim loses times the amount of money that he loses. In other words, it can be written like this. What's the probability that Tim wins? Well, half the time. So I'm going to say 1/2 times how much money would he win, or does he win, every time he wins. He gains $1 every time he wins. Plus, what's the probability that Tim loses? Well, half the time. And he doesn't gain, he loses. And so this is important, we're going to write this amount as a negative value because he's not gaining, he's losing. So negative $1. So in other words, this all amounts to $0. In other words, Tim indeed breaks even. Okay, he breaks even. Now, this is an example of a fair game. Fair game, because Tim breaks even. It's a fair game. So this leads us to a formula for expected value. Now, keep in mind that Tim's expected value was calculated by multiplying the probability of an event occurring by the net amount that Tim either gained or he lost if the event occurred, right? So this is the probability, 1/2. This is the probability of Tim winning, and you multiplied that by this net amount that he gains. And then you add that to the probability of Tim losing. And really, there's only two outcomes here, right? Two events. Either Tim wins or he loses. In general, there can be more than just two events. So we're going to look at that kind of scenario in the next few examples. But in the Tim and Barbara story, there's only two outcomes. Either Tim wins or he loses. So you have the probability that he wins, that this event occurs, times the net amount that he gains, plus the probability that the other event occurs, which is him losing, times the net amount that he loses. Okay, this leads us to the following formula for expected value. Okay, capital E for us would represent expected value, and P sub 1 represents, that's a subscript, okay? The 1 is a subscript, but P sub 1 represents the probability of the first event happening or occurring, times A sub 1. Now, A sub 1 would be the amount either gained or lost if this event happens, plus P sub 2 represents the probability that the second event occurs times the amount of money either gained or lost if that event occurs, plus the probability that a third event occurs times the amount of money that is either gained or lost if that event occurs, plus etc. Right? How many are there? Well, it depends on how many different events can occur. So let's just say there are n different events that could occur. So it'll go all the way to P sub n times A sub n. So this is the formula for expected value or expectation. All right, this expected value sometimes is called the average or the mean result that would be obtained if this experiment, remember, is performed many, many times. All right, let's look at our first example. All right, Spirit Airlines is considering adding a route from Pittsburgh to Nashville. Before making a decision, the company needs to consider many factors, including potential profit or loss. After considerable research, Spirit estimates that if it adds the route, there is a 60% chance of making an annual $800,000 profit, a 10% chance of breaking even, and 30% chance of losing $1 million. How much can Spirit expect to make annually on this new route? All right, notice that there are 3 different events, right? There's the $800,000, there's breaking even, and then there's the loss of $1 million. Okay, so there's a gain. I should say that first. Okay, there's a gain of 800,000, breaking even, and a loss of 1 million. So there's 3 different events. All right, here we go. So E is expectation, okay, expected value. And this is, of course, Spirit Airlines expected value. So it's going to be this formula. All right. There we have it. All right. Now, P sub 1 represents the probability that the first event occurs, which is a profit of $800,000. So what is the percent? What is the? I gave it away. What is the probability that that first event happens? 60%. Okay. So what is that as a decimal? 0.6 is the probability that they're going to make a profit of $800,000 times the amount. So that's times 800,000. All right. Plus, let's go to the second event. The second event is them breaking even. What's the probability that that occurs? 10%, which is 0.1 as a decimal, times the amount gained or lost. While breaking even means they didn't lose and they didn't gain. It's 0, right? Plus, I'm going to have to go to the next line here, guys. Plus the probability that the third event happens. Now that is 30% chance, right? So 30% is 0.3 times. Now, the amount gained or lost, this is $1 million lost. So we have to write negative 1 million. Okay? That's important that you write 1 million as a negative value because that represents a loss. So when you do all of this math, feel free to use a calculator, you have a positive result of $100 $180,000. Make sure you write dollars because that's what the unit is. So, what's the conclusion? Spirit Airlines has an expectation or expected average annual gain of $180,000 for adding this particular route. All right. Remember, this is also called the expected average annual gain, okay? Or just expectation. Now, we have to keep in mind, however, that there is still a 30% chance, 30%, that they're going to lose $1 million if they add this route, okay? So it's still a risk, right? It's still a risk for this company. All right, let's look at another example. All right, I like this question. Maria is taking a multiple choice exam in which there are 5 possible answers for each question. The instructors indicate that she will be awarded 2 points for each correct answer. She'll lose 1/2 point for each incorrect answer, and that no points will be added or subtracted for answers left blank. Here comes the questions. If Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess? Question number 2. If she can eliminate one of the possible choices, is it to her advantage or disadvantage to guess at an answer? All right, so let's answer the first scenario, this question here. Let's find the expected value. All right, I'm going to use capital E. All right, this is for the first scenario, okay? Is it to Maria's advantage or disadvantage to guess if she doesn't know the correct answer? All right, so how many different events are there here? Well, if she guesses, there's only 2 outcomes. She guesses correctly or she guesses incorrectly, all right? So then it is P sub 1 times A sub 1 plus P sub 2 times A sub 2, right? If she guesses, there's only 2 different things that could happen. All right. Now, let's let P sub 1 represent Maria guessing correctly. P sub 2 would be that she guesses incorrectly. Now, remember, there are 5 choices. 1 correct answer. So what is the probability that Maria guesses correctly? Well, 1 out of 5, right? 1 correct answer out of 5. That is her probability, which as a percentage is 20%, okay? So you can write that as a decimal if you want, 0.2. That's up to you, 0.2. If she guesses correctly, she gets 2 points, okay? That's a gain. Now, plus the probability that Maria is going to guess incorrectly. Well, out of 5 choices, 4 of the answers are incorrect. So this probability is 4 over 5, which as a decimal is 0.8. It's 80%. The amount she's going to lose, right? She'll be deducted points. How many? 1/2 point, right, for this event occurring. Remember to write that as a negative value because she's losing. All right, this is 2/5 minus, when I multiply by fractions, folks, you don't have to do it this way like me, but I do it this way. 2 divided by 2 is 1. 4 divided by 2 is 2. And then I multiply straight across. So 2 times 1, 5 times 1. So I call that cross canceling. So then it's 2/5 minus 2/5. The answer is 0. So Maria's expectation is 0 when she guesses. So what that means is over the long run, she will neither gain nor lose by guessing. So she's going to break even. All right, so that's really great for Maria to know, right? So if, I don't know, if I were Maria, I'll just go ahead and guess then, Or maybe she wants to finish the exam early. She's like, then I'm not going to guess at all, so I can just finish this and move on. I don't know. All right, let's go to the second question. if she can eliminate one of the choices, like maybe one of the 5 options, maybe one of them is silly or outrageous or just doesn't make any sense. So it's like, well, let's get rid of that answer. So now there's only 4 options left. Okay, let me move this up here. Hopefully that's enough. Yeah, that's pretty good. All right, so let me change the color here. Let me change it to, just change it to white. All right, here we go. So what is the expectation for the second scenario? All right, well, again, she's guessing. Yes, she's guessing at the question. So she either guesses correctly or she guesses incorrectly. So my point is, there's only 2 events. Hey folks, if I don't put the multiplication symbol right in the middle like I did earlier, see this dot means multiplication. If it's not written, it's assumed to be multiplication, all right? All right, so again, let P sub 1 represent the probability that Maria guesses correctly. Now, what's the probability? This time around, remember there's only 1 answer, but now there's only 4 different questions because Maria was able to eliminate one of them. So the probability is 1 out of 4. Again, that's the number 1. If you want to write that as a decimal, it's 0.25 or 25%, okay? And if she does guess correctly, remember she gets 2 points for that. Plus, what's the probability that she will guess incorrectly? Well, there's 3 incorrect choices out of 4, right? Remember, because she eliminated one of the 5 questions or one of the 5 answers. So this is a 0.75 or 75%, and she will be losing a half point if she guesses incorrectly. All right, so what is all of this? This is 2/4 minus 3/8. Hey folks, I did something different here just to show that you can multiply fractions differently. I didn't cross cancel. Well, I couldn't cross cancel anyway because there is no common factor between 2 and 3. So I just multiplied straight across. So I could have done that earlier. Let me move the board. I could have multiplied straight across here. 4 times 1 over 5 times 2. So that would have been 4 over 10. So this would be 4 over 10. But then you need to simplify, which is 2/5. So if you cross cancel, it takes care of the simplifying. You don't have to simplify at the end. But if you don't cross cancel and you just multiply straight across, then you have to simplify in the end if possible. But in this example here with these fractions, because 3 and 2 don't share a common factor, neither do 1 and 4, other than 1 of course, when you multiply straight across to get 3/8, this fraction is already simplified. Okay. Remember that you cannot add or subtract fractions that are not like fractions, which means if they don't have common denominators. The LCD, the least common denominator between these 2 fractions, will be 8. So then I'm going to have to multiply this first fraction by the number 1 in the form of 2 over 2 in order to get that fraction to be a fraction whose denominator is 8, right? So whenever you multiply any expression by 1, it does not change the value of that expression. That's why we say whatever you do to the bottom, you got to do to the top, right? And that's because that way you're multiplying by 1. So 2 times 2, of course, is 4. 4 times 2 is 8. So then 2/4 is equivalent to 4/8. Now we can do the subtraction, and we get 1/8. So interpreting our result, since this is positive, it's a positive answer, not negative, it's a positive answer, we know Maria will, on average, gain a 1/8 point each time she guesses when she can eliminate one possible choice. So this is over the long run. So in the long run, I would, if Maria was able to eliminate one of the possible choices, I would say go for it. It's worth it to guess. All right, let's look at another example. All right, I like this example. For an outdoor concert, event organizers estimate that 20,000 people will attend if it's not raining. Only 12,000 will attend if it is. On the day of the concert, there's a 30% chance of rain. So let's figure out the expected number of people who will attend this concert. All right. Now, so E always represents my expectation. Okay. Now, as far as events, how many different events do we have? Just two. It either rains or it doesn't rain, right? It either rains or it doesn't rain. So the formula will be P sub 1 and a P sub 2, right? Only two events. All right, so here we go. I'm going to let P sub 1 represent the probability that it rains. Now, the meteorologist says that there's a 30% chance that it will rain. That means 0.3, right, as a probability. Times, now, this A sub 1 represents the amount gained or lost. So here, the amount would be 12,000, positive, right? Because that's how many people are showing up. So 12,000 people showing up if it rains. Plus, I'm going to let P sub 2 represent the probability that it does not rain. Now listen, if there's a 30% chance of it raining, that means there's a 70% chance, right? Which is basically 100% minus 30%. There's a 70% chance that it does not rain, which is 0.7. And you have 20,000 people showing up if it does not rain. All right, so let's do this math. 30% of 12,000 is 3,600 people. And 70% of 20,000 is 17,600 people. So this total, oops, I'm sorry, wait, I think I did the wrong number. Oh, I'm sorry, this number's wrong. Hold on. This number right here. 7 times 2 is 14, isn't it? 70% of 20,000 is 14,000. There we go. This sum here is 17,600. So 17,600 represents our expectation or our average number of people who will attend the concert. Pretty cool. All right, here we go. Jaden is a real estate broker who has a contract to sell a house. Such a contract is called a listing. So Jaden estimates that this listing will cost her $2,500 for various expenses, including advertising. Jaden has to pay these expenses whether she sells the house or not. If Jaden sells the house within 6 months, she will receive a commission of $15,000. If she does not sell the house within 6 months, the listing will expire and she will not receive a commission, but she still has to pay the $2,500 for those expenses. Jaden estimates that the probability that she sells the house within 6 months is 75%. So let's determine Jaden's expectation for this listing. All right, here we go. E for expectation. Now, there are only two events, right? Either she sells the house within 6 months or she does not sell the house within 6 months. So then the formula is P1, A1, it's really P sub 1, right? A sub 1 plus P sub 2, A sub 2. All right. All right, here we go. I'm going to have the P sub 1 represent the probability that Jaden sells the house. She says it's 75%, which as a decimal is 0.75. Now, if she sells the house within 6 months, she gets a commission of $15,000. But hold on just a second. $15,000 is not her net amount. That's her gross Earlier, when we were writing down this formula for expectation or expected value, A sub 1 and A sub 2 represents net amount. In other words, she gets a check for $15,000, but she had to first, out of her own pocket, spend $2,500. So I'm going to subtract the $2,500 that she had to spend, and that's going to leave her with $12,500 net amount, right? So that amount goes in right here, $12,500. So be careful that you're not putting $15,000 there, because that's not all profit. That's her gross amount, but it's not her net amount, because she first had to fork out $2,500. So just be careful over there. All right, plus the probability, P sub 2 represents the probability that she will not sell the house within 6 months. Now, if there's a 75% chance of selling the house within 6 months, then that means there's a 100% minus 75%, which is 25% chance that she will not sell the house, which is 0.25. Now, if she does not sell the house within 6 months, she does not receive a commission. But she still has to pay the $2,500 for those expenses. So now she's down, or in the negative, $2,500. So I'm going to put negative $2,500. I hope that makes sense. So you're going to want to be very careful about what values you're plugging in to the formula, okay? All right. Okay, so doing this math here leaves you with $8,750. So this is Jaden's expectation. Now, what this means is if Jaden has more listings like this one, with these probabilities and these amounts, in the long run, her average net gain is going to be $8,750 per house. Okay? But we have to keep in mind, it's important to remember, there's still a 25% chance that she's going to lose $2,500 on this listing or on similar listings with these probabilities and amounts. So there's still a risk involved, right? But this is the expectation amount. All right, folks, let's move on to the next example. All right, when Josh attends a charity event, he is given a free ticket for the $50 door prize. A total of 100 tickets will be given out. Determine his expectation of winning the door prize. Okay, first of all, 2 events only, right? And this will change. Eventually, I think I do have a problem where there's more than one event, but there's only 2 events here. Either Josh wins or he doesn't, all right? So his expectation is P sub 1, A sub 1, plus P sub 2, A sub 2. All right, here, what is the probability P sub 1 here represents for me that Josh wins? Okay, what's the probability that he wins? Well, imagine all the tickets are in a bucket or something, or in a hat or whatever, in a bowl. There's 100 tickets. Only one of them is his. So then his probability is pretty low, right? 1 out of 100. If he wins, he receives the $50 door prize. Plus, what's the probability that he loses? Pretty high, right? Out of 100 tickets, 99 are not his. So 99 over 100, that's the probability. So it's very likely that he's going to lose, right, everybody? That's what that means. So that's his probability that he will lose. Now, watch this. What is the amount? Well, if he loses, he doesn't win the door prize. But he's not down any money because he did not buy this ticket. It was given to him. So his loss here is $0. In other words, he's not out any money from his own pocket, right? He didn't spend any money buying the ticket. It was given to him. It was free. It was a free ticket. So he goes home neither gaining nor losing, right? If Josh loses this raffle, he neither gains money nor does he lose any money. So make sure that's 0 there. So anyway, that's the formula. So then it is 50 over 100. And so the answer is 0.50, or just 1/2. So this means Josh's expectation in the long run is 50 cents. All right. Let's consider another problem that's similar to this one, but this time we're going to assume that he purchased the ticket for this door prize, all right, for this raffle. This time around, he's forking out some money. All right, we still got Josh, same dude, at the same charity event. This time around, the cost of the ticket is $2, and he buys one. What's his expectation? All right. E for expectation, or expected value. Again, there's only 2 outcomes. Either he wins or he loses, right? Either they draw his ticket or they don't. All right. There's still 100 tickets in the bowl. Only one of them is his, and so the probability of him winning is still pretty low, 1 out of 100. But now watch this. If they pull his ticket, he wins the door prize of $50. But wait a minute. That doesn't mean he's going home with a net gain. The key word is net. Net gain of $50, because he had to spend $2 to play. So this amount is going to be $50 minus the initial $2 that he had to fork out to play. So he's really going home gaining $48. So be super careful to put the net amount in this formula. All right. What's the probability that he loses? Well, 99 tickets are not his, so that's 99 out of 100. So it's really likely that he's going to lose, okay? I don't mean to be the bearer of bad news here, but it is very likely that, Josh, you're going to lose money here. And if he loses, he does not win the door prize for $50, right? But that means he's going home that night losing how much money? -$2, because that's how much he had to spend buying the ticket. All right, very good. So then this is 48 hundredths minus 198 over 100. See, technically you could cross cancel here. 2 into itself is once, and 100 divided by 2 is 50. I just decided to multiply straight across. Hey, be careful, folks, here. I want to remind us that there's an implied or invisible 1 that's underneath -2. So if you view -2 as a fraction and multiply straight across, be careful. It's 99 times -2 and 100 times 1. Sometimes what we do is mistakenly multiply 99 by 2 and we multiply by 100 by 2. No, it's 99 times 2 over 100 times 1. So just be careful with your arithmetic there. Anyway, this is -150 over 100, which is -1.50. All right, this means his expectation is -$1.50 when he purchases one ticket. Okay. Now, it would be interesting if you played around with this on your own. What happens if he says, you know what, I'm going to buy 2 tickets, right? If he buys 2 tickets and you compute his expectation, you should try that. The answer will be -$3. -$3. So in the long run, he's losing even more money, So it would be interesting to know how many tickets would he have to purchase in order to break even. But anyway, these are just questions that you can explore on your own. Let's go to the next example. It's a similar example. But this will be an example where finally we have more than just 2 different events. All right, so this is going to be fun. All right, 1,000 raffle tickets are sold for $1 each. One grand prize of $500 and 2 consolation prizes of $100 will be awarded. So they're giving out 3 different awards. The tickets are placed in a bin. The winning tickets will be selected from that bin. Assuming that the probability that any given ticket selected for the grand prize is 1/1000th, right? Out of 1,000 tickets, there's only one that will be awarded the grand prize of $500. So that's 1/1000th, right? That's the probability that you get the grand prize. And the probability that any given ticket selected for a consolation prize is, that should say 2 over 1,000. Okay, because there's 2 consolation prizes. Let me change that. Okay, sorry about that. That was just a typo. All right, so there's 2 consolation prizes. So this is your probability that you'll get one of those. 2 out of 1,000 tickets total. All right. So Irene is choosing to play. All right. So what is Irene's expectation if she purchases 1 ticket? And then what's her expectation if she purchases 5 tickets? All right. So let's go for the first scenario. So Irene has decided to only buy 1 ticket. All right. Here we go. Expectation. There are 3 different events. 3 different events here. The first event is that Irene wins the grand prize. Okay. The second event would be Irene wins a consolation prize. And the third event is nothing, right? She doesn't win anything. So those are the 3 different events, right, that could happen. The 3 different outcomes. Either Irene won a grand prize, won the grand prize, or she won one of the consolation prizes, or she won nothing at all. All right. So here we go. So it's going to be P sub 1, A sub 1, plus P sub 2, A sub 2, plus P sub 3, A sub 3. So there's 3 different things that could happen. All right. P sub 1 for me represents she won the grand prize. Woohoo! Right? What's the probability that she won the grand prize? Well, 1 over 1,000. Very unlikely. How much money will she gain net? What is the net amount that she gained? Well, don't say 500 because she had to spend $1 for the ticket. So it's 500 minus 1. So it's $499 net gain. All right, cool. Plus, P sub 2 represents what's the probability that Irene wins one of the consolation prizes? Well, it's 2 over 1,000. And the consolation prize is $100, but she had to spend $1 on that ticket. So it's 100 minus 1, so it's $99 would be her gain, her net gain. What's the probability that every time they pick a ticket, it's not hers? Okay, so first of all, you can think of it like this. They took out there's 1,000 tickets, right? 1,000. They took 1 out for the grand prize winner. They took 2 tickets out for the consolation prizes. That's 3 tickets altogether that they took out, that they drew from the bin, and none of them were hers, right? So how many tickets are left in the bin? 1,000 minus 3, which is 997. There are 997 tickets out of 1,000, right? So this is the probability that she is not going to win anything, so it's very likely. This number is really close to 1 whole. So it's very likely that she's not going to win anything. All right, anyway, I wanted to show you really quickly before we move on. I know I don't have a sub 3 right here yet, okay? But side note, the probability that she does not win a prize is 1 minus the probability that she wins the grand prize minus the probability that she wins one of the consolation prizes. So this arithmetic leads you to 997 over 1,000. So this is the mathematical way of finding the probability that she does not win a prize. Start with 1 whole, which is 100%, minus this probability, minus this probability. Leaves you with that third probability that we have there, okay? Anyway, if she does not win the prize, anything, then she's going home down or in the negative $1 because that's how much she spent out of her pocket to buy the ticket. Okay? All right, let me erase this. All right, and let me move this up a little bit. Okay, so then this is 499 over 1,000 plus 198 is 2 times 99 over 1,000 minus 997 over 1,000. And this leads you to negative 300 over 1,000, which as a decimal, if you'd like, is negative 0.3 or negative 0.30 if you like, but negative 0.3 is fine. All right. So this represents that Irene's expectation is negative 30 cents per ticket purchased. In the long run, if she continues this pattern, in the long run, that's how much she is losing. Oh, I put the negative on the wrong area, folks. Hey, folks, you see this negative right here? I think I did this earlier. You may want to change your notes. This negative, that's really weird that I put it right there. It should be on the outside of the dollar sign. Here, let me fix that really quickly. I think I did this earlier, so if I did, then just go back in your notes and change that. There. Negative, right, 30 cents per ticket. All right, let's answer the second question. What happens to her expectation if she purchases 5 tickets? Well, if this is her expectation per ticket, let's just multiply this by 5. That's the short way of doing it, the faster and easier way of doing it. So, because Irene is losing 30 cents for each ticket she purchases, that means if she purchases 5 tickets, all I got to do is multiply this expected value by 5. And that's going to give me negative $1.50. That's now her expected value if she buys 5 tickets. All right, now let's talk about fair price. Do you remember our friend Josh in the previous example where he is either going to win or lose, right? And we found that his expectation, this was in example, I think 6 it was, I think. If you go back to example 6, his expectation was negative $1.50. Now what we want to do now is determine the price that should have been charged for a ticket, so that his expectation would be $0. In other words, what should the price of the ticket be in order for him to break even? That's the question. So let's play around with this. Remember, E stands for expectation. Remember that he's at that charity event, right? And there's a $50, I think it was a $50 door prize or something like that. So, and there was 100 tickets sold. Let's say that the tickets were sold for, I think they were sold for $2 or something. You could look at example 6 before, but in the earlier part of this lesson, I think the tickets were pretty expensive in that his expectation was negative, right? So what if the tickets were cheaper? What if the tickets were only 50 cents? If you look back at example 6, you'll see that there were 100 tickets sold. So his probability that he wins is 1 over 100 because there was 100 tickets sold. But watch this. If he paid 50 cents for the ticket, the door prize is $50, I believe. Let me go back to in my notes. Hold on. Let's see. Yes, $50. The door prize is $50. But if he paid 50 cents for the ticket, then his net gain is $49.50. Right? Plus, the probability that he loses is 99 over 100. And how much he's going to lose is, well, he's going to lose his 50 cents that he bought the ticket for. So then this is 49.50 over 100, a decimal fraction, minus 49.50 over 100. Watch this, $0. So if Josh paid 50 cents per ticket, his expectation would be $0, $0. So in other words, the 50 cents in this case is called the fair price of the ticket. So the 50 cents is called the fair price because it's the amount to be paid that will result in an expectation of $0. The fair price is determined by adding the cost to play, how much you have to pay to play, to the expected value. So this is how we're going to find the fair price. The expectation or expected value plus the cost to pay. All right. In this example, we're referencing example 7. I think that's the one with Irene. Okay. In that example, the cost of the raffle ticket was only $1. And we determined that the expected value was negative 30 cents. Remember, we determined that Irene was losing 30 cents in the long run per ticket that she bought. Determine the fair price for this raffle ticket. All right, so the fair price we just determined, oh, it's still on the board. The fair price is the expected value plus the cost to play. So therefore, it would be the expected value, negative 30 cents, right? That's expected value, plus how much was it to play? $1. $1. So therefore, the fair price of the tickets would have been 70 cents. Meaning in the long run, you would expect to break even. Okay. Now, the second part of this question says verify this. Verify that this would give you an expected value of $0. All right, so let's do it. So this is for part B, everybody. Here we go. Now remember, this is Irene. Remember, you can scroll back if you'd like, but this is Irene, and there's 3 different outcomes. You can win the grand prize of $500. You can win one of the 2 consolation prizes for $100. Okay, or of course, your ticket cannot be drawn. Right? You can walk away not winning anything, right? And so there's 3 different events. We want to show that this formula leads to the value of 0. Okay? In other words, we want to prove that 70 cents is indeed the fair price for these tickets. All right, here we go. All right, so for me, piece of 1 represents the probability that Irene wins the grand prize of $500. Please remember that there are 1,000 tickets sold. So the probability is really low here that she wins the grand prize. Now, remember that she spent 70 cents for the raffle ticket. So that means the net amount that she would gain would be $499.30, which is basically $500 minus the 70 cents that she had to spend for the ticket. Plus, now the probability that she wins one of the 2 consolation prizes is 2 over 1,000. Now remember, the consolation prize is $100, but the net amount would be $99.30, which is basically $100 minus the 70 cents that she had to pay to play, the cost to play, right? Plus, piece of 3 is the probability that she does not win. Remember, that was 997 over 1,000. And she's going to lose 70 cents because that's how much she had to pay to play, the cost to play. All right, so let's do this math. So then this is 499.3 over 1,000 plus 198.6 over 1,000 minus 697.9 over 1,000, which is equal to 0 over 1,000, which is 0. We did it. So in conclusion, if the raffle tickets were sold for 70 cents instead of, how much were they before? I don't know. They were too much money. If they were sold for 70 cents, then in the long run, the expectation would be $0. In the long run, we expect to break even. All right, for our last example of this lesson, we're asked to find a fair price. So at a particular game of chance, the expected value is determined to be negative $1.50. And the cost to play the game is $4. Determine the fair price to play the game. All right, let's remember the following. Fair price is the sum of the expected value and the cost to play. So in this example, the expected value is negative $1.50. The cost to play is $4. Okay, so that means $2.50. So this is our fair price, the fair price to play this game. What that means is it's too expensive to play this game, right? If the cost to play this game was $2.50 instead of the $4, then the expected value would be $0. Okay, so the fair price is less than what it is listed right now. For $4, that's too high. It needs to be $2.50.